is a coordinate the line will never touch. In this case, if our equation is simplified and we get the same polynomial in the numerator and the denominator, this can be cancelled. When this happens, it automatically becomes a whole. The whole is part of the domain, but it's never part of the vertical asymptote, and it's only the x value when we make this equal to 0. Once we get the x value, we replace this on the simplest form of the equation and we get the y value. When we put this on the graph, we put it as an open hole or an empty hole instead of a hole filled.
Okay, so we're gonna get the vertical asymptote. The vertical asymptote is the vertical line that the graph gets near to but never touch. So for getting it, we're gonna follow these 3 steps. First of all, we're gonna factor, then we're gonna cancel, and then we're gonna find the roots of the denominator. So we're gonna factor first. This numerator cannot be factored, but this one, the denominator can. So we have this polynomial, and for factoring, we get the factors of this 3x and x, and we find 2 factors of minus 10, minus 2 and plus 5. Then we cross multiply, and we get plus 15x and minus 2x. We do the addition, and we get plus 13x, which is this, so that means that the factorization is correct. So we can write this as f of x equals 3x minus 2 over 3x minus 2 times x plus 5. So we can get like this. Then we're gonna cancel the similar or common factors in numerator and denominator. So these ones are those ones, and we cancel them out. So we get a simple form, which is 1 over x plus 5. Now what we're going to do is find the roots of the denominator. So this is our denominator. Roots means the solutions of x when the denominator equals 0. So it's this, then pass to the other side, and we get that x equal minus 5. That means that our vertical asymptote is in x equals minus 5.
The horizontal asymptote is the horizontal line the graph will always get close to but never touch. In this case, we should consider 3 rules. If the degree of the denominator is less than the degree of the denominator, y will equal to 0. If the degree of the denominator equals the degree of the denominator, the leading coefficients will divide. If the degree of the denominator is greater than the degree of the denominator, there will be no horizontal asymptote. In our equation, the degree of the denominator is 2 and the degree of the denominator is 1. So the rule that applies to this equation is rule number 1. And so the horizontal asymptote, y is equal to 0.
Okay, so our domain. The domain is the possible values for x in the graph. So we know already that we have a vertical asymptote in x equal minus 5. So it's this line. And we already know also that we have a whole, which is 2 over 3, 3 over 17. Okay, so these are the 2 values that our x can have. They cannot take the value of minus 5 because it will be on this asymptote, so it's a contradiction. And there's a whole here, so also x cannot be 2 over 3. So our domain will be minus infinity to to minus 5 with a parenthesis because we don't actually touch the minus 5, union with minus 5 to 2 over 3. It's parentheses in both because we don't actually touch the minus 5 and the 2 over 3. And then union with 2 over 3 to positive infinite. So this is our domain. We can also write it as x different from minus 5, comma 2 over 3.
Now I'm going to find the x and y intercept. This is our original function, and I'm going to be using the simplest form, which can be which was got by my partner by factorizing this and canceling. Where does the x-intercept occur when y equals 0? So we evaluate for 0. Here we will get a contradiction. Therefore, there is no x-intercept. The graph will never touch or anything in the x-axis. Now, where does the y-intercept occurs when x is equal to 0? So now we will evaluate when x is equal to 0. And this is our y-intercept. We have a contradiction in the x-intercept, and we have a y-intercept, which is equal to 1/5.
Range is all the possible values y can have. In this case, we should consider the horizontal asymptote, which is y equals 0. As you can see in our graph, the line comes from quadrant 3, from negative infinity, and gets close to 0 but never touches it. And from quadrant 1, it comes from positive infinity and goes up to infinity. So we should also consider the whole, which is 3 over 17. And so the range is gonna be y is not equal to 0, 3 over 17 because they are the only 2 points the graph will not touch. Whole is a point, and 0 is gonna be all the complete horizontal asymptote. We can write it like this, or we can write it like this.
Okay, so we're gonna graph this. We already have our y-intercept, x-intercept, the vertical asymptote, horizontal asymptote, domain, range, and whole. So we're gonna put right here our whole is 2 over 3, comma 3 over 17. It's right here. We already know that our vertical asymptote is minus x equal minus 5, so it's right here. And we know our horizontal asymptote is the x-axis. So what we have to do right now is to put values on x and find the y, so we put them there. Let's sketch this. We're gonna do this with the simplest form of this, so it's gonna be like 1 over x plus 5. Why? Because this we're gonna have the same in this and this, in this parentheses, in this parentheses. So they're gonna cancel out. So it's gonna be like the same as evaluating with this. Okay. So let's start. We have to find points in this side of the vertical asymptote and in this side, so we can know how a bit the graph behaves in both sides. So let's try with minus 4. Okay, 1 over minus 4 5. That's equal 1 over 1, which is 1. So we're gonna put it right here. Right here. Okay. Then let's try with something like minus 3, for example. Sorry. It's 1 over minus 3 plus 5. That's equal to 1 over 2. 1 over 2, right? So it's right here. So we're seeing that this is gonna get when x is getting closer to minus 5, it's going to try to reach this vertical asymptote, but it will never touch that. And we also know that the graph crosses here, so we can say that our graph do something like this. But we have to be careful with this because we know there is a hole here. It's gonna be something like this, right? With a little hole there, which is 2 over 3, 3 over 17. The coordinates of it. Now we're gonna want to see how the graph behaves on this side. So let's try with minus 6. 1 over minus 6 plus 5. That's equal to 1 over minus 1. And that's equal minus 1. So we have here. Let's try with minus 7. Minus 7 plus 5. That's equal minus 1/2. So we have minus 7 right here. And minus 1, something like here. So that's it. So we know our graph will try to get to the x-axis, but because the x-axis is also horizontal asymptote, we'll never touch it. And we also try to reach this line, but also it will never touch it. So it will be like this. So this is our graph. This side never touch the x-axis. This side never touch x equal minus 5. This one never touch x equal minus 5. Never touch the x-axis, and be careful with the hole. So this is our graph. So that's it. Thank you.